All right, hi AP kids. This is a quick tutorial on how to write verbal and math models, in case you don't remember from freshman physics or any other time you might have done it. So basically you're going to have some kind of a graph. Okay, in this case, it is position versus time. Okay, and then you're going to have some kind of a line, let's say for now. All right, and so the first thing you want to do is identify the shape. Identify the shape of your graph, okay, which is going to tell you the math relationship. All right, we'll do some other ones later, but for now this one's a line. So you're going to start with your general equation of y equals mx plus b, okay, and that's going to also help you figure out the verbal model. Okay, so based on the mathematical relationship, that's going to tell you how the variables relate to each other. So the verbal model, in this case, very simply, it usually says as the x variable increases, the y variable does something. Okay, that's kind of an easy way to do it. So in this case, we'll say as the time increases, the position, okay, in this case it increases. It may decrease or stay the same. And then sometimes you're going to want to add a qualifying word. Like in this case, we could say linearly, could say proportionally, but it's not really proportional in this case. Maybe something like that. I guess you could kind of say proportionally, but it's not really proportional. Evenly, even might be okay. All right. Something to indicate that it's a line. Okay. So that's how your verbal model is going to read. Your math model, once you have your general relationship, your y equals mx plus b, you're going to fill in something for each of these. Okay, because y equals mx plus b can be any line in the world, but I want this line of this graph. Okay, so in this case, it's going to be my y variable, which is position, okay, is going to equal my slope. And then if you look in Desmos, I don't know, maybe it's going to give you some kind of a slope, right? 9 meters per second, right? Because a slope is a rise over a run, or a delta y over delta x. So then your units are going to be meters and seconds. All right, so 9 meters per second. My x variable is the time. Okay, and then plus my y-intercept. Let's say this is at 5 meters, whatever it was, who cares? 5 meters. Okay, all right, so this is how you're going to write a good mathematical model. And then we need to maybe put it into variables that we can use. So position, we're going to use the variable x because it's usually going to be in the x direction. It could be y or z or something else later. And that's going to be the final position at a certain time, which is going to be 9 meters per second times t, okay, plus 50, oops, oh no, not 50, 5.0 meters, okay? And oops, that's not what I want to put. Well, yeah, I could put that, I guess. 5.0 meters, okay? So the first thing I want to do is replace the variables with like a symbol to make it simpler. And then I want to sort of get this more generic, all right? So in a lab situation, you would stop here, right? Because this is going to be the equation of this exact graph, all right? A step past that then, actually, I think that'll go on the next video. Let's just leave it there for now, okay? Right, so you're going to fill in your x, you're going to fill in your x variable, your y variable and your x variable, and then you're going to plug in your slope, and you're going to fill in your y-intercept, okay? And we'll just leave it there for now.